All right, guys, you get me in this fun voice today. We're going to learn about convection and weather, which is extremely important as we start looking at the atmosphere and how air cycles around the planet. The heat from our planet is all from light energy coming from the sun. And that light energy is going to hit the ground, and that ground is going to absorb it. So whether it's hitting the ocean, whether it's hitting land, if it hits metal, concrete, ceramic in the rooftops, whatever it's hitting, that area is going to absorb that light energy. The heat energy is going to be transferred to the atoms in the ground, and then that heat will then heat up the air above it. So light energy comes in, heats up those atoms of what it's touching, and then that whatever that is touching, that heat energy is going to heat the gas in the air around it. When that air is heated, it expands and it becomes less dense. That's because molecules that have more energy, they're going to move faster. And so that the area they take up is going to be a lot larger. Expand, becoming less dense, and it's going to rise upward. But then once it goes up, we've learned rising air is often going to precipitate, and it's going to lose that energy. So it's going to cool down, then it's going to sink back down to the ground. This happens everywhere. Everywhere. It's happening in the mantle. It happens anywhere where we have uneven heating, which is happening. So hot ground, this ground is hot. It warms up the air above it. That hot air rises. It then cools as it goes up, becomes more dense, sinks back down again. This is another example of convection current. So we have it happening in our atmosphere, we have it happening with air, we have it happening in the mantle, all these different examples of convection. So as I mentioned, when this is happening in the air above us, sun moves down, heats up the ground, conduction heats up the air, and that convection rises that hot air. It then cools, sinks, comes down again. And this is all because of convection. So this circular movement is happening everywhere. And because of it, it causes the movement of air and therefore the movement of wind. So we can see these happening in many different examples. This is one of them right here. If you've ever been to the ocean, you've seen and you've felt these convection currents. So during the day, our sea is a lot cooler. Our land is warmer because the sun's hitting the land and it's much easier to change the temperature of the land. So the land is warmer. This air is going to rise up. It's going to move out over the ocean where it's going to cool down. So it's going to sink and flow back again. So when this happens, we get this cycle forming, and the difference between the warm air moving up and the cold air moving down causes a breeze on the shore. So this breeze is going from the ocean onto the shore because of the change in pressure with the warm air moving up and the cold air coming down. At night, we have the reverse because now the land is much colder than the ocean. So the ocean is warmer, the air is warmer, so that warm air is going to move up, move on over, cool down, drop, and then move back out to the ocean. So we're going to feel a breeze going from the land to the ocean at night, all because of convection currents. Now, this cooling of air we're going to call adiabatic cooling. As we're going to learn later on, is that the temperatures are going to drop as we increase in altitude. So as that air rises up, it has water with it. And as the temperature decreases as we rise up, that air is going to cool. And that's because of this adiabatic cooling process that happens. All right. Most important idea here that we've got to remember. Rising air gives us clouds and rain. So that means when that air comes back down, it is dry. So rising air, we get clouds and rain. When air is dropping, we have a high pressure system and it's gorgeous sunny days. So as you're going to learn about in another video, the layers of our atmosphere, the air can only move up so high. So this cloud formation is only going to happen in the troposphere. That's because this heating of the ground that drives this convection, that movement of the air up can only go as high as the troposphere. So when we're looking at our cumulus clouds, they're only going as high as the troposphere. So just keep that in mind. So it's the limit of our convection process that can happen. Now, we've talked about this before. I just want to reiterate it again. As the warm air rises, it's taken molecules with it. And so there's very few molecules at the ground level. We call that low pressure system. So we've talked about this many, many units ago, but low pressure is when warm air is rising, causing that precipitation. Then that cool air is going to sink. It's going to pack more particles near the surface. All those molecules are being pushed down to the surface, causing higher pressure. Air is always going to move from high pressure to low pressure. So that means wherever that in between is, we're going to get breeze. We're going to get changes in wind. So in this top area here, there's going to be a flow of air that's going from this hot air moving up to this cool air moving down. So the breeze is going to flow this way. But on the surface level, this cool air is moving over, is heating up and becoming this warm air. So the breeze is going to move in that direction. So one more time, we're not going to forget this. Rising air gives us rain and clouds. That's a low pressure system. Dropping air gives us a high pressure system, which is sunny skies. So I'm sure you've seen before these cumulonimbus thunderclouds. They're very prevalent where in my home state in Colorado, but these massive thunderclouds. What's happening inside of there is this convection cell. Air is moving up and down and up and down, all the way as high as we can into the top of the troposphere, building these massive clouds. These thunder clouds are very turbulent because of this constant movement of air. So planes normally fly around these. I'm sure you've been on a plane before where they had to redirect around these cumulonimbus clouds because of that intense amount of convection that is happening all within this column of clouds. Now I want to talk about this thing called a rain shadow. So we have talked about how air can move and how it's going to carry moisture and everything with it. One example of this is when you have air off the ocean. Air coming off the ocean has a lot of water in it. And we normally have this prevailing wind that's blowing it into the continent. That's going to lead to what we call a rain shadow, especially when there's mountains. So when we have this air coming off the ocean, pushing moisture into a continental area where we have mountains, this air is going to move up the mountains. And as it moves up the mountains, it's going to cool. And what do we know about wet air? Air with a lot of water vapor, when it cools, it condenses. And so all of that rain is going to condense on one side of the mountain. But then when that cloud moves to the other side of the mountains, there's no water left in it. So we call this a rain shadow. One side of the mountain has lots of rain. It's like a rainforest. But then the other side is a desert because no water was left when it hit this side of the mountain. Here's a great example of it. So here's our mountain, here's our coast. Our winds are going to drive this warm, moist air, and it's going to rise up the mountain and condense, causing rain, 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 rain. But then when these clouds move to the other side, there's no water vapor left. So the dry air is going to cause this rain shadow. It's going to be very low in moisture, more like a desert or a tundra on the other side, not a lot of rain. This is a great example here. These are the Cascade Mountains in the US. And look at this area here. Wow, so green, so green, so green. But then on the other side, massive desert. So you're getting this rain shadow effect. Lots of rain, but on the other side, no rain. So it becomes a desert. Okay, that's all I have for you today. Most important part to remember with convection is that air rises, causing storms and raininess and low pressure, and then that air drops afterwards, dry as can be, causing high pressure systems that are full of lots of sun and no moisture. Okay, we'll talk about this more in class.